Everyone, welcome again to Physics Academy. For today's lesson, we will be covering about mass and weight. So please bear in mind that in physics, mass and weight are two different physical quantities. Alright, but when we speak in our normal daily language, when we ask someone how heavy the person is, then we will ask the person, what is your weight? But in physics, we do not ask that question. We will ask the person is, what is your mass? Alright, because mass and weight are two different quantities. So what is the difference? Let's see through this lesson. So we will start the lesson by understanding what is mass. So mass is basically about how heavy or how light an object is. So to determine that the heaviness or the lightness of an object, it includes the understanding of how many atoms are there in the object. It depends on the number of atoms in the object. So because of it is depending on the atoms in the object, therefore the definition of mass will be about the amount of matter in an object. So the amount of matter shows us that how much or how many atoms are there in an object. So if an object is light, that means the number of atoms in the objects are lesser than the object which is heavy. So a mass is basically is an amount or is a physical quantity that will not change unless the object is being cut off or the object is being broken into different pieces. Other than that, the mass will not change even though it is being brought to different planets. Because the amount of matter in an object will still remain the same. If you bring a cat from the earth to the moon, the cat will still remain as a cat. It doesn't mean that the cat become lighter, right? The amount of the number of atoms, the amount of water, the heaviness of the bones will still remain the same. Unless when the cat reaches the moon, right, you do not feed the cat food and the cat becomes skinnier and then it becomes lesser. That shows that the cat maybe the cat do not drink water, so therefore the mass of the cat will change, right? But we do not talk about that kind of changes usually in physics. So we just think about we are bringing one object from one place to another place. The mass of the object will not change. All right. So the mass is also will be affecting the inertia of the object. What does it mean by inertia? The word inertia means the resistance of the object to some changes. Right? Inertia means resistance of an object to changes in its states. Right? So therefore, the larger the mass is, the larger the inertia of the object is. Or we can say that heavier objects have larger inertia. So what does it mean in the simple standard understanding? It means that when an object is heavy, it is very difficult for you to change the state. That means to change it from not moving to become moving. Or if the object is heavy and it is already moving, it will be very difficult for you to stop it because it has a large inertia. So inertia is something that we can't see, but we can experience it. Right? We experience it when we are trying to make a heavy table move. Compare it with the trying to move a lighter table. Or we are trying to push a bicycle instead of trying to push a car. So a car is heavier, therefore it is more difficult for you to push a car. That means it is more difficult to change the state of the car. Initially the car was stationary, so the state is stationary. And to change it to moving, it will be very difficult because it is very heavy. So that is a property of the car which is trying to resist the change. You are trying to push the car so that it moves, but the car is resisting it. So that is actually the inertia of the car. Right? And in physics, mass is measured in kilogram. That would be the standard unit. Or the symbol for it will be kg. That will be the SI based unit for mass. Right, the standard international unit. Also at times there will be unit of gram being used. Keep in your mind that whenever the unit used is gram, you may need to change it to kilogram in order for you to use some specific formulas. For example, if you need to use the formula to calculate resultant force equals to mass times acceleration, so you will need to change the mass into kilogram because the acceleration is usually in standard unit, which is meters per second squared. So therefore, the mass must also be in a standard unit. And now we will go into the understanding of what is weight. So as I mentioned earlier in the lesson, that mass and weight are two different physical quantities. So what is weight? Right? So to understand weight, it is as simple as it is the gravitational force that acts on a mass or on an object. That means weight is not a single physical quantity. Weight is actually a force. A force which is where when you have an object, let's say of mass 2 kilogram, you have an object of mass 2 kilogram hanging in your hand and you let it go. When you let it go, the object will fall down. So in normal language, we say that the object falls down, which is not wrong. But in physics, we will look at the situation as in the object is being pulled down by Earth. So since it is being pulled down by Earth, so there is a force which is acting on the object downwards, which is known as the gravitational force. And since this gravitational force is acting onto the object, so we call this force as a weight. Weight of the object. Right? So bearing in mind that every object that we have in our hand or wherever we place them, if they are falling near to the surface of the Earth, they will all fall down. Therefore, weight is a force which has a direction which is always downwards. right? So weight can also be calculated. Weight has a symbol of capital W, can be calculated okay, so maybe I have jumped it too fast. What we can say here is that weight is affected by the amount of gravity a planet has. So that means a planet with a higher gravity, if you bring an object to that planet, the object will experience a greater gravitational force. If you bring it to a planet which has a lower gravity, then the object will be experiencing a lower gravitational force. So for example, if you bring the 2 kilogram object, if you have the 2 kilogram object on Earth, let's say we come up with a drawing. We have the Earth, you have a 2 kg object, and it is falling, and this is Earth. And you have the same object, which is 2 kg, it is falling, but this time it is falling on Moon. So logically thinking, we know that on Moon, a person will be experiencing lesser gravity. So that will mean that the weight of the object on Earth will be higher than the weight of the object on the Moon. Right, because the gravity on Earth is higher than the gravity on Moon. And the gravity on Earth has a value which is 10 meters per second square, or the gravitational field strength or we can call it as gravitational field strength on Earth, okay, denoted by the letter G, is equals to 10 Newton per kilogram. That would mean that for every 1 kg object that you have on Earth, it will be experiencing a 10 Newton force, which is pulling it down. So you will make it fall down for every 1 kg object. If it is 2 kg, then you will be experiencing 20 Newton. If it is 3 kg, then experiencing 30 Newton of force. Right? Therefore, by understanding the last statement here, we can come up with the formula that is required or we can use to calculate the weight. So formula to calculate weight will be given by the mass multiplied with the gravitational field strength of the planet. So on Earth, the G value is near to 10. The actual value of the G value is 9.8 Newton per kilogram. But for IGCSE purposes, it will be rounded off to 10 Newton per kg. Right? So by using this formula, we can calculate the amount of weight, which is the force, acting on an object on a specific planet. If it is not mentioned in the question what planet is it, so we will assume that the question means it is on Earth. The value of G will be 10. Right? So through the formula, you can also know that the weight is also affected by the mass. The larger the mass is, the larger the weight will be. Or if you have the same mass, but you are changing planets from lower gravity value to a higher gravity value, that will also affect the amount of weight. So weight is a force which is also a vector, and it is always pointing downwards. So weight is always pointing downwards. no matter wherever the object is. Right, so I hope that this lesson has given you a good understanding of mass and also weight. So hopefully it will be very helpful to you. So I'll see you again in our next lesson. Thank you.